All right, sixth grade. We are going to start by reviewing section 3.3, which is where we left off on. Since I haven't seen you guys in like a week and a half, I wanted to just quickly go over what we talked about with igneous rocks prior to our break, so that you're able to complete the open note quiz this evening for section 3.3. All right, so firstly, I just want to go over what we did. So I put together a little um, Google slideshow. This will kind of help review what we talked about in class, and I will also post this, or I have also posted this to Classroom, so you have access to this now. All right, so Chapter 3, Lesson 3, we talked about igneous rocks. In Chapter 3.2, or Section 3.2, we talked about basically what is a rock and how do we classify rocks. Remember, we said that rocks are um, made up of one or more minerals, and that we're going to classify these rocks based on their mineral composition, which we can oftentimes determine by their color, but sometimes not, their texture, as well as their origin. And we talked about how origin is how our book um, organizes the rock. Igneous being rocks that were formed by magma and lava, sedimentary, which is rocks that were formed by sediments um, building up along the sides of rivers and at the mouth of a river and compressing over time, and then metamorphic, which started out as a one type of rock and then through heat and pressure became a different type of rock. And this section we are talking just about igneous rocks. So just to remind you, an igneous rock is formed when molten rock, which is magma or lava, cools. And this either happens on the surface of the earth, like you see up here with the volcano. This would be when lava comes out of the mouth of a volcano, comes down the side and cools, and that forms igneous rock. Or it can happen underneath the surface of the rock in the upper layers of the mantle, where the mantle gets to a point where it cools enough to harden into rock underneath the surface of the earth. So it would be either magma cooling or lava cooling that is going to form igneous rock. All right, how do we classify igneous rocks? We classify igneous rocks basically the same way we classify rocks in general. Origin, texture, and mineral composition. All right, so we'll start with origin. So the origin of igneous rocks goes along with where did that rock form. And there's two origins. There's two types of igneous rocks. There's extrusive igneous rock and intrusive igneous rock. Extrusive igneous rock is rock that forms from lava that erupts onto the Earth's surface and cools. If you think about it, extrusive starts with an EX, just like the word exit starts with an EX, so or exterior starts with an EX. So it's going to cool on the outside. Some characteristics that go along with this cooling on the outside is that the lava cools really quickly. So extrusive rock typically has very small crystals, or it has crystals that aren't visible at all. Some examples that we looked at in class were basalt, pumice, obsidian, and scoria. And all of these are extrusive igneous rocks, or rocks that formed on the surface of the earth. And here are some images. We did these in, we actually worked with each of these in class in our virtual rock activity, which we will go over on Wednesday. But remember, basalt is going to be an igneous rock that we find on the ocean floor. Pumice and scoria were kind of formed in the same way, meaning they were kind of like a molten magma foam that came out the top of a volcano, cooled very quickly, and so you had all of these gas bubbles be trapped inside that foamy magma. And then when the rock cooled and the gas finally escaped, you are left with these little holes. So both pumice and scoria have that texture where it's almost like very, very holy. Obsidian, and we had a sample of obsidian in class as well, also is an extrusive rock, and it cools very quickly to the point that there's almost no crystals and it has like a glassy texture to it. So if you remember, the obsidian was kind of like a glassy black. All right, so those are extrusive rocks. Intrusive rocks are the other origin, and intrusive rocks, again, are going to cool within the surface of the earth. So it's going to be in the top layers of the mantle, which, remember, we call that the lithosphere. And when that magma gets close to the surface of the earth, to the upper mantle, it doesn't have the heat to maintain its molten quality, so it cools and it forms and it hardens into rock. But this happens very slowly as compared to extrusive rock, which hits the air outside and cools quickly. The rock, the cooling that happens with magma underneath the surface of the earth takes a very long time. And so you have the ability for this rock, or this rock has the ability to form very large crystals as a result of the extended time that it takes to cool. And some examples of intrusive rock would be granite, diorite, pegmatite, and gabbro. Now, granite and diorite were two of the ones that we had on our virtual lab activity as well. Remember granite? I had that big sample of granite in class. Granite, you can see the different minerals that make it up, right? Here's some feldspar. We probably have some mica, some quartz, and then maybe some quartz here too with the white. Diorite, we talked about diorite, you had a sample of diorite as well, is also very coarse grained, has large mineral crystals that you can see. Pegmatite and gabbro are the same way. See, pegmatite, you can see, again, they all look in some ways very similar, though they do have differences in terms of what they are made up of, which gives them their different colors. But they have that speckled or spotty appearance because the crystal formation is large, and so we can see the individual minerals in the crystals that they form. All right, so those are some intrusive rock examples. And then we talked about classifying igneous rocks by texture. So texture is the second way that we can classify igneous rocks, as either fine-grained or coarse-grained. Remember, fine-grained means that it's going to be you may only be able to see the grain with the microscope, or you may not be able to see it at all. Again, that's typically going to mean that the rock cooled very quickly, and it was an intrusive rock. Coarse-grained, you're going to see those grains, just like, so this granite, this diorite, these are all coarse-grained because I can see them. I can see them. They're going to have large crystals, and this coarse grain is very common for intrusive rock. So the texture and the origin really go hand in hand. Remember we said, even if two igneous rocks are composed of the same minerals, they can look very different based on how they are formed. And so it really kind of depends on the process of formation in terms of how they look, even if they are made up of the same type of minerals. All right? Yeah, I gave you some examples here. So here's granite and diorite. These are coarse-grained large crystals, and basalt and obsidian are very fine-grained or small to no crystals. All right, and the last way that we classify igneous rocks is by mineral composition. Most of the Earth's rock, if not virtually all, is composed of some combination of silicon and oxygen. And remember, we called that silica. When you have the combination of silicon and oxygen together in a mineral, that's known as a silica, or that combination is known as silica, and the rocks that form from it are known as silicates. All right, and one thing your book points out, if in general, if there's a low silica content in the rock, then typically the rock is going to have a darker color. If there's a high silica content in the rock, then typically the rock will be a lighter color. All right, the last part of this section we talked about was how are igneous rocks used. And some of the ways that we talked about in class were sculptures and statues. So here we have ancient Egyptians using black granite to carve sculptures. We here in the United States have some sculptures of the 4 presidents that are carved into the side of a mountain. This is granite that they are carved into. It also can be used architecturally in columns, in flooring, all kinds of government buildings. This is showing you a basilica of St. Paul outside so churches, buildings like that are going to use granite as a building material to make the structure. Tools, here we have obsidian being used as spearheads or arrowheads. And then here's pumice, and I'm sure this looks familiar to at least some of you. So pumice can be used as a cleaning agent, either in terms of removing dead skin, or also just like an abrasive cleaner. All right, so that brings us to the end of igneous rocks. This should all sound like a review because we did talk about it prior to our break. In terms of what else I want you to take a look at, on your classroom I'm going to go to course 2, but you both are the same. I want you to make sure that you look at my book images here. All right. Look at my book images, compare them to your book images. Make sure that you have this right material highlighted. Make sure you have annotations that I have. And then in terms of the class notes, these were the notes we took. Make sure that you should have a paper copy of this, otherwise you can just use mine. And here are the notes that we talked about for igneous rocks. All right. Tonight, I want you to take the section 3.3 open note quiz. I'm going to be posting it on Classroom. Make sure that's completed. And then on Tuesday, when you log in, we are going to move on to sedimentary rock and hopefully wrap that up this week. All right. Thanks for listening, and I will see you guys tomorrow. Have a good night.